Guys, I'm audible to you.
Yes.
Yes,
Yeah.
sir.
Guys, first tell me any specific thing you want me to discuss so that I can do that. Nothing, or shall I should do anything randomly? Or put maybe we
Some
start.
sounds.
Sorry,
Sir, can you do that hell wall hard
which one?
reaction? The HVZ reaction.
HVZ reaction.
Yeah.
Okay,
And Arndt reaction also.
okay. Which batch are you beta in?
Sir, fourth batch.
Nahi, which school? School batch that is.
Oh, TCRS.
TCIS. Beta, is it okay for the other student also who is there? Because that is not part of the
Yes,
topic.
sir.
Is it, are both of you inclined, right? Because that is not part of the topic which we told in the class. Can I discuss?
Yes.
Both of you, right? Okay, done. So we'll start with what? HVC. Okay, the topic was something else, right? The test for aldehyde ketones, right? But since you both are agreeing to it, I'm starting with what? HVZ, since you want that. Okay, chalo, let's
Yes.
start. Hell, Woolhart, Zelensky
So
react.
you're not sharing your screen.
Oh, my bad. Just a minute. Okay, it's fine now. Hell, Woolhart, Zelensky reaction. It's
Yes.
visible, right?
Yes, sir.
Yes, sir.
Okay, I'll start with very basic. Okay, it is what? Alpha halogenation reaction of carboxylic acid. Okay, what happens first? I will tell you how to solve the question. Then I will try to explain you via mechanism also. Okay, so imagine this is there. R CS2 COH. Alpha will be this group, right? Whatever is attached to the CO group. This will go
Yes.
and substitute RCHX COOH. X will be our what? Halogen. Okay. What reagents we use? What? The reason that we use is what? Red phosphorus plus X2. And sometimes in the exams, right, they meant some, generally it's this only, red phosphorus and X2. Water will be also there. But even if they don't mention water, we have to assume water will be there. And this generally applies to what? ClBr. Generally, this reaction yield is observed more in what? In case of Cl and Br. Okay. So we need what? Red phosphorus plus X2, H2O. Or instead of red phosphorus X2, right? They will give us what? Generally, they give 1 mole of PX3 plus 1 mole of X2. 1 equivalent they use. Both of them. So we should know that both are fine. But generally, in the NCRT specifically, what is there? This one is there. So we should know that this is the reagent which is used for what? Alpha halogenation. Okay. Make you understand more. Why they both are used in the entrance exam. For example, if I have to explain you a bit more, imagine the first we are using what? Red first plus X2. Even if water is not there, we'll assume water is there. Okay. And what else is there? PX3 plus X2. Right? Anything we can write. Why we can write anything? Because anyway, when P plus X2 is there, right? That will give us what? P phosphorus plus X2 will give us what? PX3. So they wrote write it what? Directly only. The red phosphorus react very violently with X2 to form what? PX3 only. Is that fine? And this X2 is in bit excess also. You will understand why via the mechanism. Is that fine? You know this
Yes.
reaction, right? We'll see, we'll know this reaction. Imagine ROH is there and you react with P plus X2 or, for example, PCl3. P plus X, even if they mention P plus X2, P plus X2 will form as what? PCl3 only. So anything they can mention. So beta, what will be formed over here? What reaction happens over here when ROH reacts with PCl3? What will happen? What will happen? What will happen? Imagine ROH is reacting with PCl3. What will happen? Any idea? No? But I will tell you, ROH plus CCl3 will give us what? RCl. Simply. Imagine this is there. RCOOH. And you react with PCl3. It will give you what? RCOCl. OH will go away again. This OH, and replaced with what? Cl. Is this clear, beta, to both of you? This thing, the reaction.
Yes.
Yes.
See, this just that if we just know the reaction, that is also fine. Okay, this reaction is what we have done, right? But
Yes.
we do it with the mechanism also. Mechanism is not even important, but so that you will remember a bit more. We'll learn a lot more in chemistry, right? If we do the mechanism. Okay, so that's why I'm telling the mechanism also. Okay. See now what will happen. The mechanism. Let's study the mechanism. This is there RCS2COOH. So you react with what? P plus X2, right? Right, phosphorus plus X2. Or they can, I'm repeating it, or they can write what? Or PX3. So this, imagine C instead of X2, I will take directly Cl2. So P plus Cl2 will give us what? PCl3. And you know PCl3 reacts with COH like what? This. RCS2CO Cl, right? This is what is there, right? This is what you will get,
Yes, sir.
right? Now what
Yes.
happens? You understand what tautomerism is a bit.
Yeah.
So I'll make it tautomerism very easy for you. Tautomerism happen between which carbons or which atoms? First, second, third. See, one, two, three. One, two, three. Okay. Now what will happen in one, two, three, beta? This H will go like this up, and this will come like this. This is what tautomerism is, right? H will have to go to third position, and double bond will shift to the other position. This is what happens. Okay, in 1, 2, 3 position, H will shift to the third position, and this double bond will shift to the next position. So this is what will happen, like this CH, C, OH, Cl. This is what tautomerism is. Now what will happen? This Cl2 will be in excess, right? This Cl2 will be in excess. This will further react with what? Cl2. But how it will react with Cl2? See, this is what is there, right? This come over here and this will come over here. So first, what will be formed? This resonating structure will be this, what I'm drawing right now. A bit complex, but we'll discuss in detail again. RCH negative, COCl. Now this will react with X2. It will form as what? XX. Negative will come over here, partial positive. This will leave, and you will get what? RCH. This was Cl only, XX, COCl. And when we hydrolyze RCOCl, see, when we give water, how will water react? Water will go like this. It will act as a nucleophile. This will go up, this will come back, and this will leave. So what do you get? RCOOH you get. So what do you get basically? RCOOH. So in the end, when we add water, we get what? RCHCl COH, which is our starting material. This is called what? Hell-Bullard-Zelensky reaction. I will repeat everything again, okay? I will repeat everything one by one, okay? What we did over here. It is a alpha halogen reaction of carboxylic acid. Charan, this is, we have not studied, okay? I will come to the carbonyl compounds. Somebody had asked out in some other topics, I was discussing that, okay? RCS2COH will use what? Red phosphorus plus X2 and in the presence of water, and this will give PX3 plus X2. This will give us alpha halogen compound, and the mechanism is not at all important. It's just that X will attach over where I have shown in right over here like this. That's it. H1H will get replaced and you will react with like this. Also, what I tell you, ROH and RCl will form, RCH, PCl3, RCOCl will form. And also one more thing, when RCOCl reacts with water, so water will go and attack over here. This comes back again, and the Cl leaves. What do you get? RCOH. This is also what you have to remember. Is this clear? This reaction which I have told you, hydrolysis of
Yes, sir.
RCOCl, right? Okay.
Yes.
Now we'll come to over here one by one. Okay. I will say step by step, and whatever doubt you have step by step, that you will tell me. Okay, so that we can discuss and proceed further. Okay. Okay. What will happen in the first case? RCS to COH is there, red phosphorus plus Cl2 is there, or PX is there, right? So I told you when P plus Cl2 will be there, PCl3 will be formed, and you know how PCl3 reacts with COH. So that will be what? Here COCl will be formed. After that, what happens? Tautomerism happens. What is tautomerism? 1, 2, 3. Shifting of H will be at which position? From 1 to 3 or 3 to 1, whatever you pick as 1 or 3. Okay. So this H will go to oxygen and double bond will automatically shift to the other single bond which is there. Is that fine? So what tautomerism you get? You get
Yes.
this compound. Any doubts till now?
No.
Okay.
No, sir.
Now this structure has resonating structures, right? The one which we have drawn. So it comes like this, lone pair, and the pi bond shifts like this. Because actually oxygen could have also donated. Don't get confused, but CH negative donates better because when we check the nucleophilicity, right, or which is a better nucleophile, carbon is less electronegative than oxygen, so it will obviously donate better, right? Because carbon is what? Less electronegative, it will donate better. This oxygen is more electronegative, so it will try to hold the 2 electrons with it only. So first, this forms resonating structure like this, just to show it that way. And this reacts with our what? Imagine this X2 is Cl2. So negative will obviously attack anything positive because of which attacks the poor. So this will go and attack over here, and Cl negative will, this will be negative, Cl negative will come out. Right? So this is something which is formed, and when you, in the end, even if water is not there, we assume water is there. In the end, when we give water, COCl, as we saw previously, will turn into what? COOH. Any doubts till now?
No, sir.
Any doubts till now? Is it clear to both of you people? Both are from TCS, right?
Yes.
Is it clear, beta?
Yes, sir. Clear.
Okay. Now, beta, since the topic is not this, firstly, let me ask Charan if he wants something to discuss, then we'll go to the other topics. Okay, beta? Oh,
So he
Charan
left.
left only.
Yeah, he left.
Ah, I should have told him earlier. Okay. Okay. Now we'll do the most complex one of this chapter. And Einstein synthesis.
Sir, is it complex?
Is it complex?
Yeah.
Yeah, beta, it's complex. It has been done in
Our,
your class.
our teacher gave one line. That's all.
Sorry.
Our teacher gave like one line, just
Uh, okay. Who is teaching you?
sir. Usually Narendra sir teaches us, but today he was absent. So RK sir taught us.
Okay.
So we haven't been taught this.
You're both in batch 4 only, right?
No, no.
No, sir. Sir, I'm in batch 3.
But I will pick something else, but I will tell you the basic of it. Okay. I'm not telling the mechanism. Okay.
Or it's fine, sir. I'll ask some other teacher some other day
Yeah.
because even Aryan is here, right?
Yeah. 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 Right. But no point. He's not. He have not said anything. So how can I like
Yes, sir. Yes, sir.
understand my point, right?
Yes, sir. Yes, sir. No problem.
Yeah. If you want, you can ask me separately. That will work for me. Or Lawrence is always there. Okay.
Yes, sir. Yeah.
Okay. We'll come to the back stuff again, which is what? Maybe test for aldehyde ketones in the exam. No, but the litmus, that not litmus, the test that we'll have. Test becomes the most important stuff. So do focus on the test of aldehyde and ketones. So you're
Sir,
testing
can you
the,
do Benedict's test?
yeah, I will do Benedict's test better. That is nice. Okay. So what all tests are there? One is tolerance test. One is your favorite fillings, and brother of filling is what do we call that? Benedict's. Benedict saying goes the same way as what? As our filling. No change, nothing much. Okay. Whatever is what do we call it? We'll be doing by what do we call it? Filling. Same thing will be going with what? Our Benedicts also. We'll discuss both anyway. Okay. So let's start with what? Tolerance. Okay. I won't take much time because I guess you need more emphasis than on what do we call it? Well, Benedict. So I will focus more on that only, but we have to reach over there, right? So we'll start with what first? Tolerance test. Okay. What happens in tolerance test? Either we give what? Ammonical solution of silver nitrate. So AgNO3 NH4OH, right? And what is formed from here is this AgNH3 2 plus OH negative. So in the exam, they can give this also and they can give this also depending on their wish. And it turns into what? R. So basically, if you use tolerance test, it gives you what? Tolerance reagent. I told you tolerance. What is tolerance reagent? That I have written upstairs. But what is tolerance? What does tolerance reagent does? It turns into what? RCOO negative, which acts as an oxidizing agent to what? Aldehyde. Always remember that. And what do you get? Silver mirror. So that is you get Ag also. Is that fine? Not writing the entire reaction. I guess entire reaction will be there in the notes. But I'm just explaining you what tolerance reagent does. It does what? It oxidizes aliphatic aldehydes to what? Acids. Aliphatic aldehydes to acids. And is also does what? Aromatic aldehydes. It oxidizes both
Sir,
to
tolerance test and silver mirror test are the same.
right. Because tolerance test gives us what? Silver mirror test. Is that clear?
Yes.
Okay, so
Yes.
this is what happened that aliphatic aldehyde, aromatic aldehyde. For example, this would have been there, and you give tolerance reagent, it will also turn into what? This compound, see, acid, and in the byproduct you get what? Ag. This is silver that you will observe when you do in the experiment also at the sites of the test tube. Is that fine?
Yes.
Okay. Then we pick up what? Filling solution. What happens in the filling solution? We take two solutions. First, we have to make the filling solution, right? How will we make the filling solution? By mixing solution A, 50% solution A, to solution B, which is 50%. Again, so 50-50% solution A plus solution B we mix. We should also know what is solution A, what is solution B. Solution A is what? Aqueous CuSO4 in the presence of NaOH, right? In basic medium. So it will be what? The filling solution will be in blue in color because aqueous CuSO4 is what? Blue in color. This filling solution B, which we talk about, is what? Sodium, potassium, tartrate, which is called what? Rochelle salt also. Is that fine? We'll mix both of them. And what do you get? You are able to form what? Fillings reagent. Right? How does Rochelle salt look like? Sodium potassium tartrate. How does it look like? It's Rochelle salt is called what? Sodium potassium tartrate. How does it look like? Like this. COONA, CHOH, CHOH, COOK. Right? So we mix both and we get what? Filling solution. So is that fine? Is that clear to everybody? Generally, you're getting what?
Yes.
We're adding Cu2 plus to it, right? Because CuSO4 is what? Cu2 plus only, right? Which is blue in color, right? So let's see. What will the reaction look like? Reaction will look something like this. RCH is there. You add what? 2 Cu2 plus. I'm labeling it also 5OH negative. This is in the NCRT also, so it becomes very, very, very important. RCO. So we take a blue solution and we get what? What is the observation? We get red PPT. Why? Because here Cu2 is formed, which is what? Our red PPT. Right? And we get 3 moles of water. When we check for example, tolerance, this was failing, right? Tolerance. This, what I'm doing right now, right? Failing. And for Benedict's, same reaction is also there and same observation is also there. That you will get what? Red PPT everywhere. So red PPT will get over here also, right? Just a minute, I have to
Yes.
take one call. Just a second. Did I record your lecture though?
Yeah, sir,
Yes.
it's recorded.
It's recording, yeah. Just a minute.
Yeah.
Guys, till then revise the mechanism of what do we call it? Tolerance, not tolerance. Tell me the reaction, what will happen. Take a minute. Okay. Just give me a minute till now. But take a minute, but tell me what is happening over here. Andre. Okay. How will tolerance look like? So the same observation will happen in Benedict's and tolerance, right? So what will happen over here? RCHO plus 2 AG NS3 2 positive plus 3 OH negative. What do you get? RCO negative plus AG we get 2H2O plus 4NS3. Okay. This is given in NCRT also you can remember, but you should know that in both the cases, RCH is converting into what? RCO negative. But since we are saying differently, right? I am saying the observation is same. Here also we'll get red PPT. And in Benedict, Felling also we're getting red PPT. And in Benedict also we're getting red PPT. And the starting will be blue solution. The blue solution will turn into what? Red PPT. So same thing will happen over here also, beta. In Benedict's also same thing. Blue will turn to red PPT, but some difference will be there in Benedict's and Felling since we are saying, right? Otherwise, we would have named it separate as same only, right? So reaction will remain the same. Everything will remain the same. So what you have to remember over there, that in our Benedict's, na. So what happens in Benedict solution? Benedict is also made of what? Solution A and solution B. So in solution A, what is there? Aqueous CuSO4 again, plus instead of NaOH was there in Felling. Now we have what? Na2CO3. And here we have what? Sodium citrate. Instead of what? Rochelle salt, right? We have what? Sodium citrate. What will happen in citrate? See how does citrate look like? Very simple. Imagine something like this. COH is there. COO negative. OH. COO negative. Right? So what do you get? This thing you will get. Is that fine? This is your sodium citrate,
Yes.
which it looks like this. Is that fine? What all test you have studied? Benedict's test. Right? Sorry, Benedict's you studied. What all we have to study in the test? 2,4 DNP test. Test is given by what? Test for all aldehydes and ketones. Okay, imagine this is there. And how does 2,4 DNP look like? What is the full form? DNP 2,4 dinitrophenyl hydrazine. How it will look like? First we'll do a phenyl ring. 2,4 nitro you put. And you get what? NH2. Right? This is what you get, right? NH2. Right. This is how 2,4 DNP look like. And this reacts with aldehydes or ketones to 4,2,4 dinitrophenyl hydrazone, which gives us what? Yellow orange PPT. Also, one more thing. When we check for Felling and tolerance, right? So tolerance we were checking tolerance, aliphatic aldehydes will give tolerance test. Both will form acid only. right? And uh, aromatic aldehydes also, as we discussed, will give us what? Tolerance. But when we check for fillings, right? Filling will give a test for only for aliphatic aldehyde. For aromatic aldehyde, it won't give this test. Is this clear?
Yes.
Yes, sir.
Right? Now tell me
Yes.
anything else you want me to discuss?
Sir, I don't have any other doubts.
The other guy was there.
No,
The
sir.
other guy was
Nothing
there.
else.
Okay. So please revise well for the exam. Everything is done for the exam. Nucleophilic addition, everything is done.
Yes, sir. Everything else is done.
Yes.
Okay. Wait, let me give you a few questions. Even what do we call it? Sodium hydrogen sulfide test, everything is done, right? Skiff reagent, that also has to be done. Clemens and Wilson, you have done, right?
Yes.
So I'm giving you a few
Yes, sir. Done.
questions. We'll revise together, okay? Imagine this is there. This is called Clemenson, which I am writing. Basic. And you will give NaBH4. So tell me what A will be there, what B will be there. Take your time, okay? I'm not. If you want to revise your notes, revise your notes. But you have to tell me the answer. Okay? I'll give you more questions on over here. Imagine this is there. CO, OCS3 is there. CHO. Uh, okay. And you treat with what? Lithium aluminium hydride. In the second case, you treat with NaBH4. Tell me what will be produced over here. One more thing. Third one. Imagine this is there. And you put NS2 OH negative. This is called what? Wolf-Kishner. KOH we put, right? So this is Clemenson, the first one. This is called Wolf-Kishner. And imagine over here, Cl is okay. One more question. Imagine OH is there, heat is also there over here, and you give what? ZnHg, HCl, and you give heat also. Okay. Tell me all the products which will be possible. Take 5 minutes. I'm in no hurry. If you want to revise your notes, revise your notes. Tell me what answer will come.
Yes.
So done, sir.
Okay, let's
Yes, sir. Done.
discuss. Let's discuss. Okay. So in this case, what will happen? This is Clemenson, right? So what will happen in this case?
Sir, it'll create a cyclohexene.
Sir,
Huh.
One,
cyclohexene.
Cyclohexane, na? Why cyclohexane?
Sir, cyclohexene.
Yeah. So,
so double bond will form, uh, like double bond will get reduced and there'll be a double bond form between the two carbons,
no,
right?
no, nothing like that. It's just that when CO is there, right? And when you reduce
Yeah,
it to Clemenson or Wolff-Kishner, it just turns into CS2. Nothing else happens. It does not affect the double bond.
okay, fine.
Like it does not reduce the double bond. Sometimes hardnesses can happen of double bond, but there is a high concept. But basically, double bond cannot
Okay,
happen like that. Okay.
okay, fine, sir.
So cyclohexane will be formed. Okay. In the B case, what will be formed?
So cyclohexane with
Sir,
OH.
Right.
yes, sir. With the word.
Okay. In this case, what will be formed? What all will be reduced? Will this be reduced with first case? I am taking lithium aluminum hydride. Will
Yes,
this
Yeah,
sir.
this will be reduced? This will be reduced. All will be
Yes,
reduced.
yes, sir.
All will turn into what? Like this. See,
OH.
CS2OH. This will turn into OH.
OH.
OH like this.
Yes,
And
sir.
NaBH will turn into what?
It can't reduce esters. Uh,
Yeah,
so the ester part will remain like that only.
Yes, sir.
exactly. And
And
the
the
other
other
will
two
get
will.
what? Reduced. Makes sense.
Yeah,
CS2OH आएगा. OH won't come. See,
huh.
CS2OH will come. My bad.
Yeah,
And this will be like this. OH.
and OH.
In
Yeah.
this case, third case, what will be formed? I'll take the next slide. What will be formed? What will be formed?
Just the double bond will go.
Yeah, but this will act as a base also, na?
Sir, so substitution will happen.
Oh, yeah.
Elimination. Heat is always there. See, heat is also there.
Yes,
Hmm.
sir.
Mostly, if heat is even not given, so heat will be there. Is that fine? So what will happen?
Yes, sir.
See, this is acidic H, right? So this will reduce to
Yeah,
what? Normally like this one, right?
yeah,
But this negative will come out from here, sets their product, and this will be formed over here, right? Because this negative will come out and this will go and this will leave.
yes, sir.
Is that clear?
Yes, sir.
Yes, sir.
So this will be formed. Is that clear?
Yes, sir.
Yes,
Clear.
sir.
Okay. Now what will happen? Uh, other one, fourth one, what will happen? OH is there. This is there, right? And now you're giving what? HCl, right? And what? ZnHg. So
Yeah,
in this case, what happens? Obviously, this will turn into what? Normal CS2, double bond O, that is fine. But will something
Yes,
happen to the OH? Answer is what? Yes, because this is acidic medium, right? H plus.
yes, sir.
So OH will
yes,
go and attack, this will go and this will leave, right? And since
Yeah,
heat is
yes,
also given, elimination will happen, right?
yes,
yes,
sir.
So this will be formed. So this will be the final product over here also. Is that
Okay.
clear?
Yes, sir.
yes.
Okay, guys. Any more doubts?
No, sir. That's it.
No, sir.
Okay, guys, you can leave. Have a good day.
Okay. Thank you,
Thank
sir.
you, sir.
Bye.